Hey guys, this is Mr. Poggio here. We are going through with task 2. That's number 2, colliding turtles with our coding Corona project. So you'll see on my weekly instructions, you'll have detailed instructions with videos for stuff from before and coding Corona tasks. Don't forget you want to really understand and know what's going on here with the Google Slides and instruction with step-by-step everything you need to know for tasks 1 through 7, and of course the coding blocks and their definition. So let's kind of recap where we've been. You should have already seen the number 1 Poggio Corona coding video. It looks something like this. So if you haven't seen the intro video, it looks something like this right here. And then you'll also see or have seen task number 1, which is right here. So as long as you've gone through those 2, you're caught up and you're at task number 2. I got some great examples of student work. So for those of you that were in Flower Turtle, that was task 1. I had some really good student submissions. I asked you guys to go above and beyond what Mrs. Q gave you guys with your 5-petaled white flower, and I got some really cool examples. So here's an example of somebody running their code and creating a cool looking flower. And I even had somebody do the extension, which was the painting turtles. I call that modern art. Let me go back a little bit here. But it wasn't a flower, but instead of a flower, having your agents paint their trail and leave. And this one wasn't a wiggle walk. Looks like this is a straight line. So I don't know if this is modern art. We could call this modern geometric art since it's all straight lines. But I got some really good tasks. Number 1 for you guys with flower turtle and flower turtle and painting turtles. So with task number 2, we are colliding turtles. We're gonna end task number 2 prepping for a code test. So be ready. That's kind of where we're going. I think we're to the point now. If you're colliding turtles, you're going to get a pretty good understanding by now where you're at with your code. So we'll get started with a review for lesson 2, and we're going to talk about commands. So this idea of what we're telling. Again, this is modeling and simulation all the way to colliding turtles. And we're going to talk about these commands and what we're going to tell our agents turtles to do. And I want you to think about this idea of responding to an environment. So in this case, I want to show you guys, you're going to see anything that's red, I want to turn right 90 degrees for this upcoming spaceland. Anything that's blue, I want to turn left. So I remember right is red, blue is left, and black will turn 180 degrees or go backwards. So in order to do this, we're going to need conditionals, if-then statements. If this happens, then this could happen. And we're going to be comparing our code and solutions, again, always with run code save, set up, run forever. So we're going to use these same blocks to set up and run forever our world and our turtle tab. We're going to be looking at these new blocks. The if then is right there on your left hand side, and you'll see this terrain color is going to be our stamp, and of course you're going to be able to tell your colors apart also. This would be an if then conditional for if a collide or if something equals a certain color. So you'll see we'll put this color block inside of these conditional blocks. So slide 23, you're going to be looking at something called bumper turtles, and this is a starter program in the SL Nova platform. So we're already given code. So you're just going to click on this and it's going to send you right on over there. And you're going to see it's already going to be set up with certain buttons. In fact, there's a new button that's popping up here. And this button in particular is called, I believe, Paint Landmarks. So you're going to be given this starter set, which essentially is called a remix. So that means we took one of theirs or somebody else's project and we made a copy of it. And that link takes you right here. So when you hit paint landmarks, which there you go, it's painting a bunch of landmarks. So in other words, it's just putting a bunch of H's down there. You can't go down, by the way, your code blocks you. But when you hit setup, you might be able to see, and I'll try to zoom in before I hit forever here. You might be able to see those 4 turtles right here. Well, those 4 turtles are going to just move. One's going to go straight up, one's going to go down, one's going to go right, one's going to go left. And at this point in time, I've not told the turtles, or the link has not told these turtles, the white agents here, to respond to their environment. So they're just going to keep going. So when I hit forever and I zoom back in, you'll see that those white dots are barely just moving from the outside edges, and they're making their way all the way back in the middle, and they're not doing anything to their environment. They're just moving straight back and forth, running into the edge of spaceland and then going back in that same direction. So they're just going over and over in that same spot, not responding to anything. Now, I mean, I could even increase the speed, show you guys in quicker detail. Ooh, there it is moving. They're not responding to anything. Now you're going to take your agents, and I want you to run your own model. I made some fun with this one, and I increased the size of my agent. So I added their size to be a little bit bigger. But now I'm not going to go all the way down and show you my code. But now when I hit paint landmarks, my landmarks are all set up. In fact, it is given to you in your slides, but you'll see your world tab will already be set up. So all of this is given to you in the link. All you have to do is set up your turtle tab, which is right there, which I will not click and show you. But when you set it up, you'll see again, I sized up my agents and I hit forever. You'll see my blocks will start moving. If I coded it correctly, there we go. You see the top one must have hit a black painted landmark. It looks like the one over here looks like it's moved a couple times, but all of these are now responding. Now I think painted landmarks is going to be an excellent extension when it comes to the idea of your final model for coding Corona, because these landmarks might represent a city. And anytime a city or a population comes in contact with this landmark, there could be the opportunity for spreading the virus. So that's where you're going to be going with understanding your environment with bumper turtles. This is not colliding turtles, but this is an extension of understanding your spaceland, more in particular, how your spaceland and your agents respond to their environment that you have coded on your spaceland. So there's a partial solution. To be honest, it pretty much gives you the whole thing. So it gives you an idea there of what to put in your turtle tab. And now we're going to get to this idea of dice and modeling with specific probability. So again, we're going to if-then conditionals. Here's an example of any time this specific code is telling me anytime the terrain is red and my agent runs into something red, it's going to turn right 90 degrees. So that's what we just talked about. But now we're going to get into probability, chances of things happening. So you might want to look through and read this a little bit more. But we're going to use this random block, and we're going to use the number 6. We're going to use the number 6 a lot because it has to do with dice. Just like if you roll a dice, it has 6 die or 6 sides on a dice. So if I wanted to move left randomly by degrees, I can move 0 degrees all the way to 360 in a straight circle. But this random number is going to give us a random number in between 0 to 10. So if we put 10, anywhere from 0 to 10. If we put 6, anywhere from 0 to 6. But when we're walking, we're going to do this thing called the walk and wiggle. So your agents are going to go straight. They're going to kind of wiggle forward as they walk. And think of it as rolling a pair of dice. If you're rolling a pair of dice and you're asking your agents to move to the left between 1 and 6 degrees, and then also to the right 1 and 6 degrees, they're not always going to move left. They're not always going to move right. There's going to be a possible combination. And what you realize if you fill out this sheet is that anything that as a 0 and a 1 or a -1 or a 1 and 2, or excuse me, 1 and 1 or a 2 and 2 combination will actually cancel each other out, because if you move left twice and then move right twice, you're back at 0, 2 minus 2. So you'll see actually heading straight forward with 0 change in your direction, right or left, is actually going to be more common when you go through the 1 through 6 walk and wiggle. And it's going to look like this. Hopefully this explains a little bit better. Turning left random up to 6 degrees and turning right random up to 6 degrees doesn't always mean you're moving left or right. It is going to be a random calculated probability of your heading or your direction. And just a reminder, when we're talking about heading and direction, if you're lost, remember I'm always encouraging you guys to say, hey, let's go back to your blocks and definitions, because your spaceland always reminds you which way your direction is going. And I'm hoping I got your blocks up here. Give me a second as it loads. But your blocks and definitions reminds you that you're heading, whenever you're in Spaceland, you're always going right, because that's going to be 0 degrees. So I just want to remind you guys and show you, and hopefully you've taken my suggestion, and either, if you have a printer, print out this last page, or if not, always have this tab open while you're coding, because not only does it give you definitions of all these blocks right here, but it also gives you a little cheat sheet so you could see them all at once here at the bottom. So I would totally make a copy of this if you can, or if not, just have the tab open. But here's your reminder in Spaceland. Here's your heading if you're zooming in. Your agent is always moving to the right. That means going towards 0 here. If we're asking to move 6 degrees to the left or right, that means just a little bit up here or a little bit down here. And after every pace or every step, they move once. Remember, your Spaceland has a size of 50 by 50 by 50 by 50 in all directions in an XY coordinate plane. So if we were asking it to take one step to the one step straight every iteration, it could only go 50 times before that agent hits the wall and will return and go back in the opposite direction. So again, just a reminder with your movement. So with this walk and wiggle, we're going to get our agents to walk randomly. And this is going to help us when we go into our collision model. To give you a better understanding, here's your agent's heading. It could go a little bit to the left, a little bit to the right, and depending on the random number 1 through 6 on both the right or the left commands, will ultimately determine where your agent moves. But the whole point is it's random. That's why it's called the walk and wiggle. A little self-test understanding, and I'll go through this with you guys real quick. I'm going to give you guys a coding test that looks just like this. I'll give you 4 agents. I'm going to keep their pen down so that it makes a color scheme just like this. But for instance, if I'm going forward 1, if we're looking at these colors between that little teeny red circle, the larger kind of random orange circle, the blue line that's moving at a heading of 0 degrees and then kind of fades off to maybe negative 20 or 30 degrees. And then it looks like we got a yellow straight line. So if I were pairing it with each of these code symbols below, I think yellow would represent forward going 1. So A would be yellow. If I look at B, that's your walk and wiggle. That's the random movement. That's going to be your blue. Now, it doesn't always mean that it's going to go down. That blue walk and wiggle can randomly head up a little bit if it goes towards positive direction over time. But again, it's moving a little bit up or a little bit down. And if you look at B, left at exactly 30 degrees and always moving forward once, that's your perfect circle. That's going to be the small little circle that's right in here. And D, the random 30 degrees, that's going to be your larger orangish circle. It's not a perfect circle because it's going random. It could go 1 degree, could go 15 degrees, could go up to 30, but every time it's moving a little bit randomly to the left until it makes a circle. But of course, it's not going to be a perfect circle because it's moving randomly. Now that we're understanding agents, we're going to get into our actual colliding turtles. And I know Mrs. Q did a great job of setting you guys up with this project. Let me see if I could grab Mrs. Q's project real quick. I'm sorry, here we go. I got you this time. But when she breaks down your collision model, and you could find her task not just here at the bottom where we're organizing all coding Corona videos, but we have it up here in your weekly task as well, because we kind of break it down by day. But let me find Mrs. Q's model for you guys, which is going to be right here. You'll see that Mrs. Q broke down your guys' collision model. She did again side by side and set you up with the task of creating 50 blue turtles and 5 red turtles, and then asking you to code the command of having blue turtles turn red when they collide with a red turtle. So you'll see her go through here, and here she talks to you guys about your task and this collision tab right here. And you'll see as she sets up her model, I don't think the color's coming up too well here. You'll see hers actually all turned yellow because she had fun and had to turn a different color. But you'll see when she sets up her Spaceland, She sets it up the same way you guys will with 50 blues and 5 red turtles. So once you've gone through your understanding of this collision block, you're going to start using, again, blocks within blocks by setting collisions with your turtles to specific colors, and then giving them conditionals as you do that. So if the color of the colliding is red, so if a turtle runs into something that is red, then that turtle will become red, is what that code is telling us here, and you're going to be using those blocks. And again, you're going to start a new project, 50 blue turtles and 5 red turtles, and then you're going to tell me how the blue turtles with your code can turn into red turtles when they collide, and some extensions to make your project a little bit more into your code. You could add probability, the chance of a blue block, or excuse me, a blue turtle turning red upon collision. You can also add extensions with probabilities and commands. You can create landmarks, like I showed you at the beginning with landmarks. You could make a landmark, for example, a city, which I think could be a great model for your coding Corona. And you could also make a third or fourth color. I think you've seen in my final model, I use 3 different colors, not just for healthy and infected, but also those that are severely sick or possibly could die because of fatal conditions from respiratory challenges with COVID-19. And then I also have a recovery and a fourth color for those that recover from coronavirus. So you can add colors and have some fun with it as you go through this colliding model. Here are your extensions, but really all you have to do is follow the tasks at the very end of task 2. And you'll see this is the worksheet that Mrs. Q has side by side with you on her model. But your goal, one more time, and I'll zoom in for you just to help you out here. The goal is to start a new project, create 50 blue turtles and 5 red turtles, have them move with a little wiggle, and when they collide with a red turtle, have the collidee change its color to red. So here's some help with you with your blocks. And just another reminder, I always like to make sure we have extensions so that those of you that want to take your code a bit farther, you can. And some of the extensions from this one more time. Let's have some fun with this probability block, and maybe creating landmarks to represent cities or area of infection, and then adding colors because that might work out with your COVID model as you're going through the rest of your tasks. So I think that's about it for task number 2, colliding turtles. I will have at the bottom in the description, I will make sure to have Mrs. Q's video and all the related documents to help you out with task 2. Once you're done with task 2, task 3 is pretty easy. I'm just going to give you a copy of my Spaceland and say, copy it. Show me what code I used and why, so you can show me that you really understand how your code is telling Spaceland what to do, because it's not on accident. Spaceland will only respond to the code that you put in your world and your turtle tabs. Your turtle tabs telling your agents or your turtles what to do. And then, of course, your world tab, which is going to be your setup. So when you hit setup, your world is going to be set up from what you put in the code for your world tab. So I hope that's enough for today, and I will see you guys in our synchronous learning on Schoology. If you have any questions, please feel free to email me or Mrs. Q. If not, I'll see you guys at 1 p.m. on Schoology. See ya. Have fun coding.